Welcome back, ladies and gentlemen. This is the second half of our 12.2 and 12.3 notes. Yesterday we covered standard deviation and how to make a histogram and a box and whisker plot. Today we're actually going to talk about what we actually do with histograms and box and whisker plots and how we actually start to analyze some of the data that we've got in them. So let's get started. Part 1. What is a histogram? Definition. It is a type of graph used to show the distribution of data based on the frequency, or in other words, how often, of certain ranges of responses. So, take a minute, copy that down, pause if you need to, but let's look at this example. This is a collection of data from you guys' Chapter 2 test. So you guys took a test on Chapter 2 way back in September or October and collected all your data. So down here is all the scores, and up on the left is how often somebody scored in that range. So if we look over here where the majority of our data is located, it looks like about 18 students scored between a 21 and a 24. And it looks like about 14 students scored between a 24 and a 27. And I believe this quiz was out of 27 points. So what you have down here are these bins, and each bin, and that's bin, bin, that's a range of scores. So here's how many kids scored between 0 and 3. Here's how many kids scored between 3 and 6, between 6 and 9. Okay, between 9 and 12, a few more, between 12 and 15, that same amount. Another jump for 15 to 18, and then a big jump, 15 of you score between 18 and 21, and like I said, 18 between 21 and 24, so on and so forth. Okay, so that's the idea with the histogram. It's looking at the frequency of a certain range of responses, or in this case, test scores. Okay, that is what a histogram does. The mean and standard deviation come into play with a histogram. We're going to talk a little bit about distributions today, and the idea with a histogram is that this is what a typical histogram would look like, where you've got it kind of high in the middle and lower on the outside edges. And the idea with a histogram is that in a perfect world, the mean, or your average, would shoot right down the middle at this red line, and then that standard deviation should be spaced out about as far as these green lines go. Um, what standard deviation should tell us, so we talked about yesterday, it's all about how much the data varies, so how far away it spreads from that mean. Generally speaking, we expect approximately 68% of our data to fall between one standard deviation to the left and one standard deviation to the right of the mean. So if I look at all my data in this range right here, I'm expecting about 68% of all my data, whether it's quiz scores or survey responses, I expect about 68% coming between one standard deviation plus or minus of the mean. So with histograms, we generally like to use mean and standard deviation when we do our analysis and when we look at the data, because that's kind of what they're designed to give us. They should give us a good, clear picture of where the majority of our data shows up. So the next thing we need to talk about, though, is normal versus skewed data. We talked about this a little bit. So this would be a normal or symmetric distribution of data. And the idea here is that your data is distributed evenly. Okay, so we have a lot of stuff in the middle, a lot of data responses in the middle. This middle bin has the most responses. And then as you go out towards the edge, it gets smaller and smaller and smaller on each side, roughly evenly. And in practice, it'll rarely be perfect, but generally speaking, we're going to expect this kind of a curve to show up if we say it is a normal or symmetric distribution of data. In your notes, I would probably just be sketching this. It doesn't have to be exact. And this is also taken right from your book, so you've got it there as well in chapter 12.3, I believe. Now, we have our symmetric distribution, then we also have skewed distribution. And the first one would be a positively skewed distribution. So if you looked here, the majority of our data is on the left. So it's almost like we took this normal curve over here and we kind of grab it and stretch it, pull it over to the right, kind of make that side a little thinner. So now we've got this positive skewed data. I've got some more data being pulled off in the positive direction while the majority of my clump or of my data is clumped down in the negative direction. So my little hill is skewed to the right. That's a positive skewed distribution or positively skewed distribution. Pause if you need to. And if we have a positively skewed distribution, that means we also have a negatively skewed distribution. And this is just the opposite, where the majority of the data are on the right. So most of my data is clumped up here to the left, and I've kind of pulled that tail off to the left edge here toward the negative direction. That's negatively skewed data. Okay. Now this is the part where a lot of students get mixed up, calling the positive negative and the negative positive. So it's just something I would make sure I've got in my notes. Draw that general shape so you can kind of see what that hill looks like. You can get an idea of what's positive and what's negative, while not forgetting what's a normal or symmetric distribution where it does have that hill right in the middle. So copy these graphs down. Again, they don't have to be specific. Pause the video if you need to, and also remember these are in your book if you need to reference these later. Now, the next thing we're going to look at is the box and whisker plot, which should look familiar. Hopefully you've seen some box and whisker plots before now, probably in middle school. For our definition, it's a type of graph used to show the distribution of data, much like with the histogram, except now it's going to be based on the middle data point, which is that median that you've heard of before, as well as the highest and lowest data points. So if we look at this example over here, dealing with players' weights on a football team, and I just ripped this off the internet, but you'll notice the key points we have are the minimum, the maximum, and the median. Okay, with these lower and upper quartiles, which are like a quarter of the way up and 3/4 of the way up through the data. So bottom, quarter of the way up, halfway up, 3/4 of the way up, top. That's what we're looking at with the box and whisker plot. It's just a different way to look at how our data is distributed. Now, I just kind of mentioned this, but where the histogram really serves us well with the mean and the standard deviation, the box and whisker plot deals with what we call the 5-number summary. The 5-number summary consists of the median, that middle data point. Half our data is below it, half our data is above it. The minimum, the smallest data point, so in this case, what's the lightest player on the team. The maximum, the heaviest player on the team. And then that lower quartile called Q2, this is the guy who's got 25% below and 75% above. And in the upper quartile, he's like 3/4 of the way up. So 1/4 of the team is bigger than he is, and 3/4 of the team is smaller than he is. So it's 3/4 of the way up through the data. That's the 5-number summary. It's these 5 points. And then also you'll be asked for the range oftentimes, and the range is just how wide of the spread is the data. So you take the maximum, subtract the minimum, and that's the range. Again, the range is the maximum minus the minimum. I don't have that one written out, so make sure you write that in your notes. One more time, the range is the maximum minus the minimum. Okay. Pause if you need to get the rest of this down. The 5-number summary we could actually find using the exact same steps we did yesterday to find the standard deviation. So if you had a calculator, you would press this stat key again, clear out all of your old list, input your data into L1 very carefully to make sure you don't have any errors, and then it would be stat calc 1 variable stats, and then which was option 1, and then press enter, and that'll give you all your stuff. Yesterday we talked about how we were looking for the mean as option number 1, and that population standard deviation. This down here in red, and let me see if I can get this guy to go away. It's not going to go anywhere. That would be the 7, 8, 9, 10, and 11 spots. Will give you the minimum, the lower quartile, the median, upper quartile, and maximum. And please note that when it says we'll deal with this later, this is later. Okay. Just to note, and I would make sure this is in your notes, to find this, you will have to scroll. So you're going to have to click down, down, down a few times once you do the one variable stats to get to this. A lot of students mess that up and they all of a sudden can't find it and they think it's broken. It's not. You just have to scroll to get it. And also, please realize that they don't actually spell out lower quartile. They would just label it as Q2 and Q3, which were the notes we used on the previous slide. Well, several previous slides. Lower quartile is Q2, upper quartile is Q3. Okay, pause if you need to. Okay, so part 4, normal and skewed data. We can also look at normal and skewed data from a box and whisker plot. So if we have symmetric data, this basically means that the whiskers in both halves of the box are roughly the same length. And the median, so the way the book puts it is the whiskers are the same length and the median is in the center of the data or the center of the box. Okay, that's symmetric data. Similarly to what we saw with our histogram, if the right side is longer, so now we've got the median over here off to the left and the right whisker is a good deal longer than the left whisker, that's positively skewed. And then if it's the opposite of that, so now the median is on the right side of the graph and this side is kind of stretched out to the left, that's going to be negatively skewed data. And again, this chart is taken right out of the book, so you can always dig this out of there if you need to see it again. Okay, that is our analysis of box and whisker plots and histograms. So you have another worksheet that's going to have you practicing with this some more. Fill that out, ask each other questions, work together as you need to. You have the substitute there to help out, and do your best on this. Thanks, guys.